Hey, you're 11. Recently got you guys started on linear functions. I've seen these before, but obviously we're into revision mode and a lot of us need to improve on that. So we're going to look at linear functions. And, invariably, some students will ask, why are we bothering? Why would I ever need to know something like this? And to be honest, right now, we've got a coronavirus kicking about the place. A coronavirus is not a linear function. Okay, it's not linear function. You might even heard people saying, "Hey, this coronavirus is affecting people at an exponential rate." Results or infections increasing exponentially. So, and that looks a little bit like this: exponential curves up like that. So not linear. Linear being a straight line. This thing's changing over time at an increased rate. And that's not to be alarmist or fearful or anything like that. But if we have time along the bottom, number of cases here, you can see the difference between even a day or two massively changes the landscape. Early on, very little changing, across here. Okay, it doesn't seem like it's too big a problem, but then it starts to snowball and things start to take off. Now, our issue really is not to have to understand how one would model an exponential function in the real world with infection rates and things like that around coronavirus, or how we might start throwing all of our resources into the system right here somewhere, maybe at that number of cases, saying, hey, look, we need to really kick on with our self-isolation and, reduce the amount of social contact we have, close borders to a degree, that sort of thing. Because we're trying to do this thing. So, get it actually kicking out over here. All right. And hopefully that is under our health system capacity. Hospitals and whatnot. Hopefully we curl it under here so we don't get, over subscribed in the hospitals. And so, as I said, our job's not to really understand how we're going to model that necessarily. A higher maths you would, but at Foundation we don't. But it's really our responsibility to understand the basic mechanics, but the interplay between this here, the time and the number of cases, the x coordinates and the y coordinates. And to do that, to teach you guys how to understand this sort of thing when it comes up in real situations that you've got to deal with in your day-to-day life, we start simple. We start with linear functions. We start with something that doesn't change, or the rate of change isn't different. The rate of change is exactly the same. And we model simple situations to hopefully be able to get you to some fairly compelling stuff later on. I'll start you with something really simple. You would have seen this one before from me. Taxi driver we're going to do here. My taxi driver is charging a cost to the user per kilometre of the fare. And I'm going to say this taxi driver is running at a £3 starting charge when you get in the car, plus £2 per kilometre, which, might be or might not be accurate. We'll find that out. So actually, you get in the car over here, 0 kilometres, and already you're starting at £3. Now, we could start modelling this and plotting points, but some people say, hey, I don't really know where to plot my next point. So often you go to table of results. And this x coordinate here, which is called kilometres, and this y coordinate here, the cost in pounds, we're going to say, okay, well, kilometres travelled and the cost is going to be like that. At 0 kilometres travel, I'm going to charge £3. That's just getting in the thing. After the first kilometre, it's 1 lot of 2 plus 3. It's going to take me to 5. Second kilometre, it's 2 lots of 2, 4 plus 3, takes me to 7. Third kilometre, 2 lots of 3, lots of 2, 6 plus 3, 9. And actually, really interestingly, some people are going, hey, look, I can see you've got this pattern. It's just plus 2 every kilometre, starting at 3, but plus 2 every kilometre. I can fill in the rest of the table without really thinking about it. 11, 13. So we've got a bunch of points we can plot now. And then really the good thing about it, we want to shortcut some of this stuff. We see some patterns. Let's use those patterns to shortcut our work. So let's go through and plot some of those. 1, 5. So 1 is up 2, it's about there. And we go, okay, 2 up 2 is about there. 3 up 2 is about there. And we're going to find this line continues on that way. Okay. If I use a ruler, obviously, perfectly straight. And that's pretty much it. Is learning how to get from this to there fairly fast. So we'll try another example. I'm going to just shift my dinosaur. My son's T-Rex is holding my phone. We're going to have a look at another example. This one here, we're going to go for a gradient or slope. That's how steep these things are. That's what we're trying to learn how they change. We're going to go for a slope that goes down rather than going up. It's going to go down here. So let's start with, again, I'm going to stick topical, go coronavirus. You've got a student that's got, let's say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pounds of pocket money. Okay, £10 of pocket money right there. Let's just shift that there. Cool. And we're going to say that actually they start with 10 quid. But, they're at home. This kid's at home, self-isolating. Good on you. And they're not doing their chores. They're not going down the shops to pick things up. They're not doing the things they normally would do to earn that pocket money. So actually, mum and dad are saying, hey, yo, you need to start pulling your weight. I'm going to start charging you 2 quid a day every day at home. Tough family. So we got minus £2 per day. I'm going to pay for your upkeep. How's that going to look? So we've got here is going to be my days along the bottom. Okay. How many days we got there? And again, you're going to start at 10 quid. So it's up here, starting at my 10 pounder. And some people say, hey, look, I can't deal with that math. Let's do a table of values to help me out. So there you go. I'll start up our table of values, and we've got day and pounds of pocket money. And we start at day 0, before we've had a day off. You got 10 quid, day 1, day 2, day 3, and so on it goes. You lose 2 quid a day. So on one day you lost 2 quid. So you're down to 8. Day 2, that's 2 days of losing 2 quid. That's 2 quid of 4. 10 take 4, down to 6 quid. 3 days, again, you're dropping down 6. So you're down to 4 quid. You can see, actually, the rate of change is always the same. It's always going down. 2. Excuse me. And you can fill in the rest of the table, should you wish, once you realise there's that pattern going on. So let's go and plot those. We go 1, 0, 10 I got. 1, 8, 1, 8. And I'm down to 2, 6, and 3, 4. And I can plot this thing out and see, and actually if I keep going, end up down there somewhere. Cool. Now all of this, these are just real modelling. We're just modelling away, and what we try and do and say, actually, these are X's and Y's. And it doesn't matter if we're talking about kilometres versus cost or days versus pocket money or anything else. We can actually learn there's some fairly predictable patterns of behaviour within these numbers. And so what we're going to do is go, you know what? What they like to do is turn it to this format. They're saying that the Y values, these are responding to these, the Y values are equal to something times the X value plus or minus something else. It's always the same. Let's check out what it was here. We've got, okay, for this one it was Y equals, or the cost was equal to, we had £3 to start, but it's £2 per kilometre. I can do, that's 2 lots, £2 per each of these. That's 2 X's. And I already had a 3 to start, so I can write plus 3. Now I've written that back to front, 2 lots of the kilometres, 2 lots of x's, plus 3. That's no real big deal. That's how they like to write them quite often. It's a nice format. And actually what it tells me is, hey, check it out. That 3 on its own is a starting point. And this 2, that represents this rate of change. Hey, look, it's this 2 going in 2s, and this goes up 2 across 1, up 2 across 1, up 2 across 1. Go down to this graph. This is a downward sloping graph. And so we do the same thing. These pocket money, the Y values, is equal to, well, I started with 10 and I took off £2 a day. I could write it one way. I could say I start with 10. I took off £2 per X per day. That works fine. If I wanted to switch it up and write it in this format with the MX's plus or minus first, I'd write Y equals, that minus belongs to the 2, minus 2x, that's a positive 10, plus 10. I can see that, hey, this number on the end, it's just a starting point. This minus 2 is this rate of change. It's saying, oh, look it out. We're going down 2, down 2, down 2, down 2 across 1, down 2 across 1, down 2 across 1. Okay, so that's really where we're going with all of this stuff. I'm going to get you practicing really, and you have been practicing just using these to pump these into tables and transfer the table onto here. And we're going to start getting more and more or faster at it and using more complex examples. We'll get to that a bit later. So I'll get you practicing a little bit more, and I'll post another video shortly. Cheers.